All right. Hello, hello, hello. This is going to be my first video, which is going to go over how to do part one of the Kepler's first law activity. So if you've already done part one, if you've already made both of your ellipses, you can go ahead and move on to my second YouTube video, which is going to be on part two, how to deal with calculating the eccentricity of the ellipse. So part one, as we indicated in class, is going to involve you using the Desmos interactive ellipse. Okay. So I already have that tab open. So let's go ahead and analyze it. So I'm going to refresh it. That way I can reset this up. Okay. The first thing you'll notice when you come to this link is you're going to have the point, the z value, that is constantly tracing the entire time when you open this. You want to press the pause button over here to make that stop. That point is going to represent the distance. It's going to represent a planet's orbit, honestly. Okay. The values that we're going to focus on is this value of d, of the value of a, b, and c. And we'll be able to make an ellipse regardless of how much you remember on how to make an ellipse. So the first thing that you're going to do, if you take a look at the instructions, so in class today, we made the two dots that were 2 centimeters apart. That was the first thing to do. We did that using a 10 centimeter loop that would trace the entire thing to make our first ellipse. For the second one, what we're going to do is we're going to make two dots that are 5 centimeters apart. Okay, we're going to have the same d value of 10, and we're just going to see what we get. So with that being said, let's go ahead and go over here and let's set up our ellipse. So the d value is going to be what we set to be 10. So let's go ahead and set this value to 10. Okay. The next thing that we're going to do, since we want them to be 5 centimeters apart, I like to set it so that the ellipse is going to be centered about the origin. Okay. So the a value is going to dictate where the red point resides. The c value is going to dictate where the purple blue point resides. And then the b point is going to represent how high the ellipse goes. So with that being said, let's go ahead. I think it's a really good idea since they want to be 5 centimeters apart, and I want to center the ellipse on the 0 point, is to put the left-hand side point at negative 2.5, the right-hand side point at positive 2.5, and then we'll just kind of go from there. So I'm going to go ahead and do that. So I'll put the A point, and you'll see as I'm typing, at negative 2.5. We'll put the C point at positive 2.5. Okay, and now you'll see that they are 5 units apart, abstractly. Now to center it, just go ahead and change the b value to 0, and that means that it will now be directly on the axis. So what you can now do is you can kind of click and drag to get a big picture, and then you can take a screenshot of this and insert the image. It just kind of depends on what device you're using, into a Google drawing. Now, I've already done that, so I'm going to come over here, and we're going to scroll down to the example that I did. So I'm going to go ahead and press the edit button, and I'm going to kind of walk through what we did. So the nice thing about Google Drawings is that you can insert pictures. And so just for fun, what I did is I inserted, you can see, a picture of Mars right here. And then I inserted a picture of the sun, just to represent that, Kepler's first law, the sun would be at one of the foci. It could be at either the left-hand side one, or it can be on the right-hand side one. Mars is going to trace out the path of the ellipse. So if you take a look at the instructions ask you to do a couple things. So it asks you to indicate the point that is closest to the sun. So if we were to take Mars, and trace its orbit all the way around, I'm doing this manually. At this point where it's closest to the sun, then we're going to leave it here, and you're going to stick a P right there. And the P stands for perihelion. Okay? Perihelion is known as the point that is closest to the sun. The next thing that you're going to do is you're going to take your plant again, and you're going to come on over here. You don't actually have to move your plant. And you're going to identify the point, and you're going to label it with an A. And the A stands for aphelion. And the aphelion is the furthest point away from the sun. Now, this kind of explains to you, if all planets have an elliptical orbit, why whenever you look up the distances, it's always going to give you an average distance because there's a point where the planet or the celestial body is going to be closest to the sun or whatever it's orbiting, and there's going to be a point where it's furthest away. Okay? Perihelion, aphelion. Now, the next thing that you're going to do, and this is for an anticipation of part 2, you're going to identify little q and big Q. Okay, and we'll talk about that in the why you're doing that in the part 2 video. Okay, so little q is going to represent the distance from the perihelion to the sun. Okay, and big Q is going to represent the distance from the sun to the aphelion. Okay, you'll notice that these two distances are different. And the more different they are, the more elliptical your ellipse is going to be. That's almost kind of a sneak preview of what's to come. The more equal these values are, you'll notice the more circular it will be. And so that's going to, again, play a big role. Okay, so I traced out some lines. I put text boxes in. The way that you can do that is just by using the line feature right here and just using the text box feature right here. Just let me know if you guys have any problems with that. Once you finish, you can go ahead and just press save and close, and it should insert your Google drawing right here. In case you are unfamiliar with how to do a Google drawing while you're in Google Docs, you just have to go to insert and then go to drawing, and you can say new right here. Okay, so once you've inserted your 2 photos, you do need to answer this question right here. So have your 2 diagrams model Kepler's first law of motion. Okay? And then the last thing you need to do is you need to write down the definitions, and you can grab these definitions from wherever. These are really your own reference. I don't mind if you copy and paste in this instance. The definitions for ellipse, focus, foci, major axis, semi-major axis, semi-minor axis, perihelion, and aphelion. In case you're having some difficulty, this video right here is phenomenal. You can grab your definitions purely from this YouTube video right here, and I think it would do you some good. So anyways, let me know if you guys have any questions, and I hope this video was helpful in completing part 1 of the Kepler's first law hyperdoc that I have given you guys.